Hello everyone. So today I will be going through this composite function questions which appears to confuse or trick most of the VCE students. So I thought I might just briefly go over it. Alright, so what does the question say? The question says that f of x is equals to x squared minus ax and g of x is equal to square root of x plus a. And what we need to do is to find the value or the values of a for which g of f of x or gof is defined for the given constraint of a is greater than 0. Alright, let's start off by visualizing the graph of f of x and g of x. So f of x is clearly a quadratic or a quadratic graph, so which is a parabola. Alright, let's start off by drawing a parabola. However, this parabola has a special property that it will always pass through origin. Now, why is that? Well, because if we are to find x-intercept for any parabola or any quadratic equation, what's our first step? Well, we see if we can easily factorize it. And in this case, thankfully, we can. So, we take out x as our common factor, leaving us with x minus a. And to find the x-intercept, we set y equals to 0. Alright, so this will result in solutions of x equals to 0 and x equals to a. So as you can see here, no matter what the value of a is, the graph of f of x will always pass through origin. Okay, so one of the x-intercept is at the origin as labeled here, and the other one would be a, 0. And let's start, and now let's see the graph of g of x. Okay, so g of x is a square root graph, meaning it will have a shape like that. And this a here, this a in this equation here, would determine where the graph would start from. So this here is a0, so this graph will move or translate horizontally, left or right, depending on the value of a. Okay. Let's find the domain of f of x and g of x and the range of both of these functions because, well, that's also another important part in composite function questions. Alright, what is the domain of f of x? Well, f of x is a parabola, and parabola always has a domain of R. There is no other implied domain, implied constraints which restricts any x value. So the domain of this parabola will also be R, which is all real numbers. The range of f of x, however, is from the y value of the turning point all the way to the positive infinity, Alright. How do I find the range then? How do I find this? How do I find the y coordinate of this turning point? Well, there are two methods. Firstly, we can simply take the derivative of f of x and set it equals to 0. Or what we can do is we can find the x-intercept as we already did before, add them up, and then divide it by 2. Now, why does this method work, you ask? Well, because the parabola is a symmetric graph, and parabola is same. It has a symmetry on this x from this axis of symmetry, meaning that the distance over here is the same as distance over here. So this distance and this distance is same. So we can simply take the average of these two x-intercept to find the x-coordinate of the turning point. However, my preferred method is to find the derivative of this function because this derivative method will work with any other function as well. Alright, so we know that f of x is equals to x squared minus a of x. So our derivative would be f dash of x is equals to 2x minus a. Very well. Now we set this derivative function equals to 0. Why is that? Well, we can clearly see that if I were to draw a tangent that passes through this turning point, we can clearly see that this tangent has no gradient or no slope. So the gradient of this tangent line is equals to 0. So hence we know that to find the x-coordinate over here of this midpoint, of this turning point I should say, is going to be when the gradient of this parabola is equals to 0. So 2x minus a is equals to 0, which results in x is equals to a over 2. Now, we know that this coordinate here, the x coordinate of this turning point is a over 2. Now, how do I find the y coordinate? Well, we just simply put it back in f of x, resulting in a over 2 squared minus a times a over 2, which is equals to a squared over 4 minus a squared over 2, which would give us negative a squared over 4. So we know that this turning point is now a over 2 and negative a squared over 4. And from this coordinate, we can easily say that our range of this parabola is from negative a squared over 4 all the way to infinity. Alright, now let's find the domain and range of g of x. Well, g of x is a square root graph, as you can see. So g of x is equals to x plus a. Now we know that for this square root graphs to be defined, the inside term, which is this term over here, has to be greater than or equals to 0. If x plus a was to be less than 0, then there will be no real solution. There will be complex one, but not real one. Since this is methods, we only focus on the real solutions. Okay, so we know that our condition for this function to be defined is x plus a is greater than or equals to 0, meaning that x is greater than or equals to negative a. Or, in a different syntax, we can say that x belongs to negative a to infinity. So, the domain of g of x is negative a to infinity. Now, what about the range? Well, the range is just starting from 0, which is y value, the minimum y value in this function is 0, and going all the way to infinity. So, the range of this would be 0 to infinity. Now, okay, this is the most crucial step done and dusted. Now, for g of f of x to be defined, we know that range of f, which is negative a squared over 4 and infinity, has to be a subset of domain of g, which is negative a to infinity. Okay, now what is this entire thing about subset? This is the part where most of the students get confused. So let me elaborate on this a bit. So rather than using this to explain, I'm going to substitute in some numbers. Say for example that we again have two data sets. One is going from 1 to infinity. Okay, maybe bad color choice. Sorry. One is going from 1 to infinity, and which has to be a subset of the other data value, which is going from 3 to infinity. Well, is this statement true or false? Okay, the most simple way to find out is using a number line. Alright, so this is 1 and this is 3. So our first constraint is 3 to infinity, and the other constraint is 1 to infinity. Well, we can clearly see that 1 to infinity does not fall under 3 to infinity, and hence this right here is false, not true, false. Now, what happens if I say that 4 to infinity is a subset of 3 to infinity? Is this true? Well, we can again simply draw a number line. Always draw a number line for these sort of questions. It will minimize the chances of any errors. So 3 and 4. Okay. So 4 to infinity, and the other one is 3 to infinity. Well, we can clearly see that 4 to infinity falls under 3 to infinity. You can clearly see that this right here, clearly showing us that 4 to infinity falls under 3 to infinity, meaning that this is true. Now what happens if I say that 3 to infinity is a subset of 3 to infinity? Is that true? Well, again, let's quickly draw a number line. 3, this is our first subset. This is our first range of data values, 3 to infinity, and the other one is 3 to infinity as well. Well, you can clearly see that it still is true statement because 3 to infinity is a subset of 3 to infinity. So this is true. So judging by these few examples, if I were to write a generalized form that c to infinity is a subset of d to infinity as long as c is greater than or equals to d. This statement is considered to be true as long as c is greater than or equals to d. Okay, we can use this generalized form here to solve our question. So I'm just going to erase everything else. Going to erase everything else. I'm going to bring this one up. So we can assign negative a squared over 4 as c and negative a as d. Now we can write this. We can write c is greater than or equals to d as negative a squared over 4 is greater than or equals to negative a. Now if I were to solve this on CAS or any other graphic calculator that your school might use, we get a value of a ranging from 0 to 4, or we can say that 0 less than a less than or equals to 4. Now is this our final answer? No, this is incorrect. Why is that? Well, we need to remember this constraint right here, that a is greater than 0. So our final answer would be a belongs to or is between 0 exclusive to 4 inclusive, simply because the question said that a has to be greater than 0. Or we can write this as 0 less than a less than or equals to 4. This is our final answer right here and not this one. So I hope you found this video helpful and I hope you liked it. Please give me any feedback in the comments on things I need to improve. Hope to hear from you and I'll catch you in the next video. Thanks for watching.